All right, for section 8.4 part 2, we have just a couple more examples to go through. So example number 9, and again, this is another review of part 1. So same kind of question that we talked about before. We have a person who leaves home and walks 2 miles west, then 5 miles southwest. So we've got this person, they leave and they walk 2 miles west, so this vector's component form is going to be -2, 0, with magnitude of 2. And then after that, the person then turns 5 miles, goes 5 miles southwest. So I'm going to look at it separately first. So that's going to be a vector that goes down 45-degree angle under west. And so they're going to go southwest for 5 miles. Okay, so the component form for this one here we need to find. So that is going to be x is going to equal the magnitude, which is 5, because we know she went 5 miles, and then 5 cosine, and then that angle here is 225 degrees. So 5 cosine 225, and then y is 5 sine of 225, and then put both of those in, and we have the vector -3.5355 and -3.5355. Okay, then we're going to take this vector and add it onto the end of her other vector. So after she walks 2 miles west, then she walks 5 miles southwest. All right, so we added that on. So now our new component form, which relates a vector that starts at the origin and ends at this same point. So then in blue, our vector here is going to be the sum of my purple vector and my first blue vector. So we're going to add these two vectors together. So that's going to be -5.5355 and -3.5355. All right, and so now we need to know how far away from home is she. That's going to be the magnitude of my new vector right here. So I need to know the magnitude of that vector. So if we know the component form, we can find the magnitude. So magnitude is going to be -5.5355 squared plus -3.5355 squared. Okay, which doing all of that, you end up with 6.568. So she ends up being 6.568 miles from home. And then that's the magnitude of that vector right there. Okay. All right, hold on. Okay, sometimes my pen gets a little tired. I have to turn it off and on again. Okay, so we've got how far away from home is she? And now we need to know in what direction she must walk to head directly home. So that is going to be this angle right here because we want to know how many degrees north of east does she need to start walking. And that angle there, because of alternate interior angles, this angle here is going to be the same as this angle here, which is the angle of our new vector minus 180 degrees. So we know that cosine theta, and this is for our new vector that we added up to find this, cosine theta is going to equal to the x value, so negative 5.355 over the magnitude, which is 6.568, and sine theta is equal to negative 3.5355 over the magnitude, which is 6.568. I only need to solve for one of them. I can check with the sign after that, but since we are working in quadrant 4, we are going to need to find a second solution, so you make sure that you keep track of that. So my arc cosine of that answer is going to give us an answer of theta. I only wrote down my first one. Hold on. I only wrote down my final answer. Okay, so when we find the arc cosine of this value right here, we end up with our first solution being 147.4368, and that is in quadrant 2, so that is not the solution we want. So we need to do 360 minus theta. So remember when we were using cosine before and we needed to find a second solution, we always do 2 pi minus. Now we're working with degrees, so 360 is our equivalent to 2 pi. So 360 minus theta is going to equal 212.56. And now, because that's giving us this whole angle from the beginning of the x-axis all the way around, we need to subtract 180 so that we get just this little portion of the equation that we need. So we're going to take 212.56 and subtract 180 from it, and we will get 32.56 degrees. And that is how far she needs to turn to head directly home. Oh, whoops. Not that. All right. So 32.56 degrees to head directly home. And that's our final answer for number 9. All right, example number 10. It's kind of really hard to kind of really wrap your head around what all they're saying. It's a lot simpler, I guess, than what it sounds like. So let's just read through it. So 2 children are throwing a ball back and forth straight across the back seat of a car. The ball is being thrown 12 miles per hour relative to the car, and the car is traveling 45 miles per hour down the road. If one child doesn't catch the ball and it flies out the window, in what direction does the ball fly, ignoring wind resistance? I'd really like to do a problem where we actually did have wind resistance, but this one does not. So we have coordinate plane. Let's go ahead and look at these 2 different situations. So we've got our car that's driving down the road. It doesn't tell us a direction, so we can just choose a direction. I am going to say that this car is headed east. So this car is headed east at 45 miles per hour, so we're going to make a vector out of that and say the magnitude is 45, and then also the component form of that vector is then going to be 45, 0. All right, we have the kids in the car right here, and these kids are going to throw a ball out the window as they're going down the road. So as they're going down the road, the ball comes flying out of the window. Okay, and it has a magnitude of 12 miles per hour. All right, now I have this positioned where it's already added onto the car. If we were just looking at just the ball being thrown out the window, then we would just put it, I gotta use 2 different colors here so we can see. This would be the ball being thrown out the window right here. So the vector for just the ball being thrown out the window, the component form, would be 0, 12. So going back, the vector that is then formed from adding the vector for the car plus the vector for the ball is going to look like this. Now we want to know what the component form for this new vector is. Now we know that this car is going 45 minutes, or has a vector of 45, 0, and this one has a vector of 0, 12. We add those two vectors together, and we come up with our new vector, which is 45, 12. All right. Now we need to know what this angle is. So we know the component form, so we need to find the magnitude. So find the magnitude of this new vector. So that's going to be 45 squared plus 12 squared, which, let's see, I think I just used the square root of 45 on that. Nope, that's not right. Let's just figure that out real quick. 45 squared plus 12 squared, and then the square root of that. Yeah, it's 46.573. I do have that there. 46.573. So that's our magnitude. So now we can find what cosine theta is. Cosine theta is going to equal the x value, which is 45, over the magnitude, which is 46.573. And then we find that. Now we want first answer this time, because we're in quadrant 1, so first answer for cosine. And the theta value that we get is 14.93. And that gives us this theta value right here, which looks excellent. I'm happy with that answer. Yep, and it is the correct answer too. That helps. So that is how you do example number 10.